Welcome to this explainer. Let's jump right in. Because today, we're taking a pretty wild spatial journey across the entire globe. We're going to start in the sweltering heat of the equator and travel all the way to the freezing, bitter extremes of the polar regions. Along the way, we're looking at exactly how the Earth's diverse biomes are hardwired to our climate. So if you've ever wondered why certain plants and animals only pop up in very specific pockets of the world, well, you're in the right place. Let's get into it. Here's our quick itinerary for the expedition today. First, nature's climate connection. Second, the tropical forests. Third, temperate and Mediterranean zones. Fourth, the taiga and extreme biomes. And finally, number 5, the future of our forests. All right, Section 1, nature's climate connection. To really wrap our heads around this huge concept, let's look at a super relatable story about a girl named Salima. She was on a summer camp trip heading up into the mighty Himalayas to Manali in Himachal Pradesh. And she noticed something brilliant just looking out her bus window. As the bus climbed higher and higher toward the Rotang Pass, the deep, dense jungles of the foothills, the ones packed with sal and teak trees, they just kind of vanished. And replacing them were these really tall trees with thin, pointed leaves and cone-shaped canopies. And then, as she got even higher up, the whole landscape suddenly transformed into just short grass and snow. So in literally one bus ride, Salima witnessed a mini version of the entire globe. Just by changing altitude, the climate shifted, and the natural vegetation completely transformed right along with it. Okay, so what's the actual secret here? What is controlling these massive shifts in plant life? Well, it really comes down to two ultimate heavyweights: temperature and moisture. These two things act like the bosses of the environment. They dictate whether a patch of land is going to explode into a towering forest, roll out into a grassy plain, or just dry up into thorny shrubs. Sure, other things like the steepness of the slope or how thick the soil is play a part too, but make no mistake, temperature and rainfall are the true architects of all natural vegetation. Moving right along to Section 2, the tropical forests. Down in the tropics, near the equator, we basically see two totally different types of forests, and it's all about how they handle water. On one hand, you've got tropical evergreen forests. These places just get hammered with heavy rain all year long. And because there's literally zero dry season, the trees never have a reason to shed their leaves all at once. They build this permanent, incredibly thick canopy that's actually so dense, sunlight often can't even hit the forest floor in the middle of the day. Then, on the flip side, we have tropical deciduous forests. These are your classic monsoon forests, found in places like India, northern Australia, and Central America. They have very intense seasonal changes. So to survive a brutal dry season, these trees pull off a brilliant trick. They shed all their leaves at once just to conserve their internal moisture. Now, the sheer scale of the tropical evergreen forest over in Brazil is absolutely mind-blowing. It's so impossibly vast that people famously call it the lungs of the earth. And because you have this thick, constantly wet canopy, it creates the perfect home for some of the most intense wildlife out there. I mean, this is the environment where you'll find the anaconda, right? One of the biggest snakes on the planet. It's a predator so massive it can literally kill and eat a crocodile. No way, right? But it's true. But let's hop back over to those tropical deciduous forests. These areas are massively valuable to us, both economically and ecologically. These monsoon forests are packed with heavy-duty hardwood trees. We're talking sal, teak, neem, and shisham. And these woods are incredibly prized for building heavy furniture, transport vehicles, and construction materials. But it's not just about what we can build with it. These dry season shedding forests are the ultimate hunting grounds for some of nature's absolute fiercest predators, like the majestic tiger. And the tiger is just the tip of the iceberg when it comes to the biodiversity here. Alongside them, you've got these magnificent creatures that are just perfectly adapted to the seasonal shifts. You'll see the incredibly striking golden langur swinging through the branches, while massive herds of elephants are making their way across the forest floor. It's just a constantly shifting, incredibly dynamic ecosystem. Which brings us to Section 3, temperate and Mediterranean zones. So while the east and northeast edges of continents usually have temperate evergreen and deciduous trees, the west and southwest margins have something completely different: Mediterranean vegetation. You'll find this around the Mediterranean Sea, obviously, but also in spots like California and Southwest Australia. And what's really cool here is the evolutionary hack these plants use to survive. They have to endure these scorching, bone-dry summers. So, to stop themselves from losing all their precious water through transpiration, they've literally evolved thick, rugged barks and these clever wax-coated leaves to lock the moisture inside. It's like they're wearing their own armor. And because of that unique, mild, and sunny climate, the Mediterranean margins have become absolute gold mines for human agriculture. They are globally known as the orchards of the world because the climate is just flawless for cultivating endless rolling vineyards, huge citrus groves, and olives. Now, as we push even further away from the equator into higher latitudes, think the northeastern USA, China, or Western Europe, we hit the temperate deciduous forests. Just like the tropical deciduous trees, these guys drop their leaves in the dry season, but the actual tree species are totally different. We're talking oak, ash, and beech trees. And roaming around these woods, you've got deer, foxes, wolves, and some stunningly vibrant birds like pheasants and the incredibly colorful monal bird. Moving into Section 4, the taiga and extreme biomes. If we travel way up into the northern hemisphere, right between 50 and 70 degrees latitude, we hit the spectacular coniferous forests. In Russian, this massive region is known as the taiga, which translates to pure or untouched, which I think is a great way to describe it. These are actually the exact same cone-shaped trees Salima saw high up in the Himalayas. They're tall, evergreen, softwood trees like pine and cedar. But listen, don't let the word soft fool you. This wood is wildly important. The pulp from these trees is literally the foundation for the entire global paper and newsprint industry. Even the matchboxes in your kitchen or the packing boxes on your porch, they rely on the timber from the taiga. So what happens if an area gets a little bit of rain, but not quite enough to actually grow a forest? Well, you get grasslands. And grasslands are incredibly diverse. In the tropical zones, like East Africa, we call them the savanna, and the grass there can grow an unbelievable 3 to 4 meters tall. But if you look at the temperate zones, it's a completely different story. The grass is much shorter, but it's incredibly nutritious, which makes it absolutely perfect for supporting giant herds of wild bison and antelopes. And fun fact, they go by different local names everywhere. The Campos in Brazil, the Llanos in Venezuela, the Pampas down in Argentina, the prairies in North America, and the Downs in Australia. Okay, so what if the moisture drops to practically zero? Well, then you find yourself on the western margins of the continents, right in the tropical deserts. When you're dealing with scorching, blistering heat and almost zero rain, having big, lush leaves is actually a massive liability. So instead, the vegetation here takes the form of really harsh, thorny bushes. It is an environment of absolute extremes. Every single drop of water is fiercely guarded by sharp spines. Finally, reaching the very, very end of our geographic map, we hit the freezing polar regions of Europe, Asia, and North America. This is the tundra. The climate here is so exceptionally brutally cold that traditional plant growth just doesn't happen. It's basically non-existent. Vegetation is strictly limited to low-lying mosses, lichens, and tiny shrubs that frantically try to grow during a super short summer window. And the only animals tough enough to endure this, like polar bears, walruses, and snow foxes, have literally evolved incredibly thick fur and thick skin just to insulate themselves from the lethal cold. And that brings us to our final stop, Section 5, the future of our forests. You know, when Salima got back from her trip, her father sat her down and showed her some photographs of thick forests from all over the world. But in so many of those pictures, people were just aggressively cutting down trees and clearing massive patches of land. And that's the harsh reality we're facing today. Local populations and large industries are rapidly clearing out these ancient, complex forests just to make way for more agriculture and sprawling human settlements. We are literally dismantling the very biomes we just spent this whole explainer exploring. And if we keep this up, the Earth is going to face a massive shortage of the oxygen, water vapor, and timber that we absolutely rely on to survive. Which brings us right to the most urgent question of our time, the exact same question Salima asked her dad. If all the forests are cleared, where exactly will the wildlife go? Think about the golden lingor, the tiger, those huge herds of elephants. Without their specific climate zones, without their exact natural vegetation, they just can't survive. Will the forests ever be able to return to their original shape? It is a deeply provocative, kind of haunting thought. But it's absolutely crucial that we figure out how to conserve this incredible, diverse flora and fauna before the damage goes completely past the point of no return. Thank you so much for joining me on this explainer today, and I really hope this journey has given you a whole new perspective on the world outside your window.